So let me just test to see if this is recording. Yes, it is. Great. We're going to be looking at cloud computing. We know what cloud computing is because we've done that in previous lessons. The whole point of cloud computing is its ability to be flexible, cost-effective, scalable for different businesses. We're going to look at how and what that actually means. So there are different services that cloud computing actually provide for different companies. One of them is data storage. So it basically allows you, I've got an office in London and in Manchester, which is 2 hours away, I could have all my data stored there on a server. Why? Because I'm using cloud data storage. It basically means that somebody else, a third party, is responsible for managing my data, security. So this involves security. It involves backing up my data for me so I don't have to do it myself. And it allows me to access data remotely. What that means, I can access it if I'm in the USA, if I'm on vacation, for example. So that is cloud storage, where it's done off-site in the cloud, so to speak. So how does it actually work? That's what you look at now. So basically, we have data centers. As we know, data centers will store servers within them. When a user, like in London, is wanting to send their data over the internet to these servers, it does so. This is my data. And what happens is it stores a copy of my data. So I've got data here, the original, the OG. So it could be like, I don't know, a spreadsheet which has everyone's figures on, their salary figures. I send it over, it gets stored onto the server as a copy. If I wanted to get into a situation where I wanted to look at the data again, I can log onto a website where I get given a nice little interface. That means like a lovely view of it. I can then just click on the link to open it. It will then retrieve the data and display it on my screens. It means I can access it anytime as long as I've got internet, and that's the same with anything to do with cloud. Examples of this are like Google Drive or OneDrive. So what's the benefits? Well, the benefits are that I can access it. So let me do benefits up here. Any location I can access. It's scalable. That basically means that if I'm running out of space on this server, because I'm using too much data, I can just start using another cloud server. Another benefit is going to be that it's reliable. It's managed by a third party like Google. So it's probably more reliable than me storing it and making my own server myself. So the next service we're going to be looking at is email. So email, which we use every day, is a service of cloud. Basically, It has a server. I should say server, but I can't spell. My gosh. So it's got an email server. When people send us an email, so let's say little Jimmy, it gets stored on the email server. I'm able to, wherever I am in the world, access my email and retrieve it. Really simple. It's a continuous service, so that means it's never down. You know, if they get a power cut, we can have backup servers, etc. So if we talk about things like Gmail, Hotmail, that would be examples. So as long as I'm connected to the internet, I can use it. It's that simple. Another service is virtualized software. We've mentioned this before as well. So that would be simply OS, operating system virtualization. This basically allows a server to emulate, that means to run many different types of operating systems, like Windows 11, Windows 10, Mac OS. So it allows this server to be able to do that. Why would that be useful? Well, here's the thing. Let's imagine that you're a game developer. You're testing out your game on a PC. You're testing it out on a Mac. And let's imagine that you want to run it, but you actually don't have any Mac computers. You've only got Windows. You can't afford Macs. What you can do is turn this to a thin client, which means it's just like a screen. You can connect your computer then to the server. The server will then pretend to be your computer. It would run Windows 11, and you can test out your game. Once you're done with testing on Windows 11, you can then change the operating system to Mac OS, and you can run the game like it was on a Mac operating system. So it's going to be cheaper for you, without having to buy lots of different hardware. You can then run it on older versions of Windows to see, okay, how would it run for people with like Windows 10, Windows 7. And another example of virtualized software is application virtualization. So how's this different? Well, application is, let me just go up. That's a great idea. It focuses on how applications run in different isolated environments. You might be thinking, okay, what the heck are you talking about? Well, let me give you an example. We've got this application virtualization tool called Microsoft App V. And what happens is we've got these different computers, so PC1, PC2, and PC3. We've got a server. And what happens from this point forward is that we can give to each one of these PCs, when I say give, I'm going to use the word deploy, basically a version of Microsoft Office. But instead of us having to install it onto this computer and then install it onto this computer, it's like take forever, install onto this computer, we actually install it on the server. We do it once. We then can stream it to whoever wants it. So this basically allows us to store it in one place, stream it, and execute it locally. That means we run it locally on each one of these computers, wherever they want to use it. It means that if there's an update to the software, we just need to update it on the server. If we want to delete it, we just delete it from the server, and we don't need to then go to everyone's machines and do it. We just do it in one place. And that's an example of application virtualization. We then have another service that cloud computing can create for us, and it's actually called service virtualization. So what is actually meant by service virtualization? Well, it's used in software development to simulate the behavior of components within an application. What does that actually mean? Well, let me put it into a nice little scenario for you. Let's imagine that we've got a development team of Joe and Mary. They're a team, and they're working on a brand new banking app. That's what we're developing. So they're working together on this banking app. Let's imagine that this banking app needs to interact with a third party. That means another company to handle payments. So let's say PayPal. Whilst we're developing, the issue what we're going to have is we may not be ready to integrate. That means do live payments with PayPal if we're still testing out the system, because PayPal will allow me to send money from person 1 to person 2, but if we're just testing, we won't be ready to do that. So what service virtualization will do is it'll create basically fake PayPal code we can then test it by saying, hey, fake PayPal, we'll give you $4, make sure that this goes to a customer, and fake PayPal will go, yep, this works perfectly, no issues. So it allows us to test things in terms of from a development side, especially if we're using third-party products to see how some software work with another, without us actually having to use the PayPal code because we're not ready for it yet. And the final service, which is very similar to what I talked about with virtualized software, is remotely hosted apps. So it's basically, again, very similar to virtualized software, where you have a server. The server has the app on it, so to speak. Anyone who wants to use the app doesn't have to have it installed onto their device. It means that we don't need to be worried about costing, because we don't need to have an install license for this one and this one, because some software you have to pay per device you install it. But if we install it on one, it saves us money. We don't have to worry about updating the software, deleting the software if we need to, any of that, because it's done on the remotely it's done on the remotely hosted application server. I need to add word hosted.